So, very good morning to one and all present for the last day. You can say the workshop of machine learning and speech processing. So, we have with us the resource person Pratyush Khan and Rohan Sahu. Uh, Actually, both are the AI engineer and technology professionals. Good morning to Mr. Rohan and Pratyush.
So,
So,
Good morning, Dr. Dash.
good morning, Dr. Dash. Good morning to you all.
Thank you
both
for
are
inviting us
the
here.
Thank you. So both are the AI engineer and technology professional with interest in speech technology, voice biometric, and secure AI applications. So mainly their work focus on leveraging AI for real world authentication and digital security solution, particularly in voice-based identity verification. So more about this, they are going to tell. And today's topic is voice authentication to detect voice clones and verify speaker identity with applications in law enforcement, banks, and e-KYC and online meetings. So whatever things covered by Dr. Jagabandhu yesterday from the Finland, so most of this practical applications or hands-on, you can say, going to be presented by our today's resource person, Mr. Rohan and Mr. Pratyush. Uh, Thank you, Mr. Rohan and Mr. Pratyush. So now session is yours, and you can start. Thank you very much.
Thank you, Dr. Dash, and good morning, everyone. This is Rohan this side. Pratyush and I are with a company called ContentLens.ai, and we are basically in the domain of content authentication, user safety, protecting likeness of individuals, celebrities, right, using various technologies like deepfake detection technologies and voice clone detection, etc. Right. Now, in today's session, what we'll do is I'll just give you a quick overview of what is lined up, right, and then maybe I'll introduce the problem statement and hand over to Pratyush from there. So today we're going to be talking about deepfake detection, voice authentication, and speaker identity verification. So its session is by myself, Pratyush, and Dr. Jagbandhu, who had a session yesterday. He's also our advisor, and he's been helping us in building out, our product. So we'll cover first the global overview and impact of voice clones. Then we'll look at the speaker verification system, and then we'll look at how do we monitor infringements, voice infringements online. Look at some other examples of voice misuse detection. Then we'll cover the applications of voice clone detection in various industries. Then there's a short demo of how our detection technology works on edge devices. So we are basically looking to deploy this on-prem and on phones and other devices as well. And lastly, we will show you how you can get early access to the product and evaluate the product and give us some feedback. So when we look at voice clones, right, the prevalence of voice clones is massive in cyber fraud. So there's almost, since 2022, there's been almost a 400% increase in voice clone related fraud incidents. Almost 1 in 5 organizations have experienced a voice cloning attempt in the past 12 months. And 9 out of 10 security professionals believe that voice cloning will become a major threat in the next 2 years. What is surprising is 50% of the voice clone fraud cases involve less than 3 minutes of audio, right? So you barely need any audio to create a good voice clone and also to implement a fraud attempt, right? So if you look at the overall impact, there's almost a 2.95 billion loss, estimated global loss due to voice clone fraud in 2024. And surprisingly, 70% of victims didn't even realize that it was a voice clone until after the fraud. And the average time to create a convincing voice clone I would say, was 18 minutes. It's actually reduced significantly now. And Pratyush will also maybe talk about it a little more. But as per published reports right now, you can see in less than 18 minutes, you're able to create a very convincing voice clone and perpetrate a fraud. So what does Content Lens do, right? So if you look at audio that is available online or the phone calls you get, so you can assume there are two types of audio that you would listen to. There is audio from the user, directly from the user, which is either from the phone or you're uploading an original audio, or there is audio taken off the user and then you use either text to speech technology. There are multiple players in that, or you use speech to speech voice conversion technology. Again, there are many players in this as well, and using that you're creating a voice clone. Now Content Lens is a deepfake detection solution, so you can actually use us to triage which audio clips are original with no tampering and which ones have some sort of tampering in place. And we are then able to triage and separate that out and tell you that this is real and authentic speech, and these clips are AI generated or AI edited speech, right? Now there's a demo. We can share the slide deck with the team, and you can maybe take a look at it. Pratyush, you could maybe cover it in your demo as well. I'll quickly also just cover what is the impact across key industries. So as per published reports, in the banking and financial services, almost 74% of financial institutions have reported increased fraud attempts in the last year. And the average loss in banking is almost $350,000. In HR and payroll, 62% of organizations have been targeted, for payroll or benefits fraud via voice cloning, and almost $200,000 in loss is estimated there. Similarly, in law enforcement, about 30% of agencies have reported being affected by voice cloning. Um, if you look at the other industries like healthcare, legal services, again, the numbers are significantly high. And overall, if you see all the other enterprises, if you take that into account, again, about 33% of them have experienced some sort of fraud out of voice cloning, right? With an average loss of about $180,000. So that was a quick summary of the impact, the prevalence and impact of voice cloning. With that, I'll hand over to Pratyush, our AI engineer who leads our speech and all of our speech-related AI work, and he will walk you through a few demos, a few live demos, and show you, how you can use Content Lens to detect voice clones and also verify the identity of the person speaking. Right? Like currently, I'm speaking. If I turn off my audio, now how do you know whether it's actually me or it's my voice clone that's playing? Right? Because these days voice clones are hyper realistic. So we'll cover that. Any questions, please feel free to stop us, and or you can use the chat box as well. We'll be monitoring that, and we'll take that in the end. Over to you, Pratish.
Thank you, Ron. So, hi everyone. I'm Pratyush, and I'm an AI engineer at Content Lens. And Ron, as just said, I lead the deepfake detection and the speaker verification products. So, I'll be going over some important demos of how these pipelines work. So, first, what I'll do is I'll go over the deepfake detection part. So, as Rohan just mentioned, there are two kinds of audios that can go into the deepfake detection pipeline. One through text to speech, and other is the speech to speech. And both of them, when passed through the deepfake detector, they get flagged as AI generated. And if you're submitting an original video, they'll be classified as real. So this is where our pipeline, or the product that we have made, works. The central theme to it is catching the voice clone no matter how you create it. Now I will show you a live example of it. So this is our deepfake detection portal. First, what I'll do is I will submit my original voice. You can either submit your original voice, or you can just upload a WAV or an MP3 file. So click on start recording. Hi, this is Pratyush, and I am speaking in my original voice. Upload content to reveal its authenticity. Click on analyze audio. And as you can see, it correctly identifies it as a real voice, or you can say a not AI generated voice. and it also gives you the confidence with which we are predicting it as AI or not AI accordingly. Now, next, what I'll do is, as you notice in one of the slides, 11 Labs these days is one of a very widely used tools to create these voice clones, and I'll be using that same example. So this is a voice clone that I have just now created. Let me play this exact voice clone for you. And one of the key features, I would say, whether it's a feature or it's a positive feature or a negative feature, that's according to that's open to the interpretation of the end user. The clones are very hyper realistic, as in, when you create it, it's very difficult to separate it from the real person. So let me just play this. So if you could, I hope this was audible. So I'll just download this file. So this was the file that I just downloaded from 11 Labs. Again, click on Analyze. And now this time it detects it as AI generated. And if you could notice, the confidence with which it's doing is very high, like near 100%. So any kind of synthetic transformation of an audio byte on an audio clip, our models are able to catch them and then flag them off accordingly. Now, this was a simple example, as in, like, you just simply created a voice clone, you uploaded it. Now, what happens is, at times there are replay attacks, as in, you are not uploading the file and you're not even speaking it, but playing it back into the system. Like, you can play it via a mobile phone, or you can play it through like a video player, or you can play it on any other tab as well. So what I'll do is, so I have my mobile phone over here, and I will play that voice clone through my mobile into the speaker. Hi, this is Pratyush, and I am submitting my voice sample number 3 to enroll into the speaker verification portal. And again, even when I play it back, yet again it's able to catch it as a voice clone and flag it off as AI generated. And yet again, if you could see, I'll just zoom this in for better viewing. Yeah, the confidence is like very high, like pretty impressive, nearly 90%. So this is how we can also detect playback attacks and flag them. And in addition to that, we also have a detection dashboard. So like, once you're registered into our registered with us, you can check on your daily detection results, your overall results. So we provide you with how many voice samples you submitted, how many were fake, how many fake samples, how many real samples you did, model accuracies, just so that you can keep a track of all your daily and global predictions. So this was the deepfake detection. Now I'll move to the speaker verification part. So the next part, so the speaker verification is the next step. Now we know it's a deepfake. Next part is, if it is a deepfake, whose deepfake is it, and how is the person using that deepfake for any authentication purposes, maybe to get into a system, or just try to get try to bypass any mechanism and appear as real. So this is where the speaker verification comes in, wherein we identify the speaker and then we check whether this speaker is AI generated, AI edited, or the person is real accordingly. And then based on that, we make business decisions. Should we allow that person to get access into a system, or maybe flag it on social media or anywhere, which you'll see later on as I go. So this is how the entire end-to-end workflow of the speaker verification is. User uploads the voice, and then we have a quality control check. Like basically we find out whether how good the sound quality is it good, is it bad, until a certain so we have mechanisms in place like checking the signal to noise ratio, background noises, and based on that we allow the user to proceed further. Then the verification starts. Now first you have to enroll into the system. When you enroll, you get a speaker ID, which I'll show you next. Then you go to the verification, enter your details. If the speaker is found, we proceed further. If no, then definitely it will deny you access. And then we have, after the speaker is found, we run a spoof detection check on it. Whether is it real or is it fake? If it is real and the speaker is matched, we grant access. If either of the two do not line up, as in even if the speaker is matched, but it is a spoof or like AI generated, then we deny access. And if both, then it's very obvious. So this also gives you whose voice is being cloned. Now I'll give you a demo of the speaker verification part. And excuse me. So you can so this is our speaker verification portal, and at the end of the presentation we have our so this is free to use for everyone. We have prepared a full set of instructions of where you can go, how you can log in, and you can access and play around with the functionality. So you can upload up to 3 voices. So let me try an enrollment attempt. So you can speak, just make sure that you're speaking at least 10 or more words with clarity, just so that the fingerprint of your voice, like fingerprint, if I'm using the word correct, is a unique identity of your voice is correctly created. Hi, this is Pratyush, and I am submitting voice sample number 1 for speaker verification portal. This was the first voice. You can submit either one or you can submit multiple. I'll show you with all 3. Hi, this is Pratyush, and I consent to using this voice sample for speaker verification portal. Now, what I'll do is, for the third voice sample, I'll try to put in my voice clone inside it. So 2 samples I had submitted, and let me just play this for you.
Pratush, we can't hear the clone.
Okay. You couldn't hear it?
No.
I will just reshare again.
Share with audio so that.
Yeah. Okay.
Yeah.
So
Hi, this is
it now audible?
Yeah.
Yes,
Yeah,
yes.
we can hear it now.
Okay. So this is the voice.
Pratyush, and I am submitting my voice sample number 3 to enroll into the speaker verification portal.
Now I'll download this voice clone. Just name it test clone 3. Then you enter your name, click on enroll. And as you can see, my enrollment attempt was denied because one of the samples that I submitted was an AI generated sample. So even when during enrollment, we have this check that if you're trying to enroll with an AI generated voice, you will get rejected. Now let's just add my real voice. I'll remove the third one. Hi, this is Pratyush, and I am submitting my voice sample number 3 to enroll into the speaker verification portal. So as you can see, this time it says, since I'm already pre-enrolled, so it is telling me that I'm already enrolled into the system and prompting me to proceed towards the verification. In case you were not enrolled, you would have, and if all your voice samples were clear, you would have been given the notification and a speaker ID. And that speaker ID we would use for the verification. Now let's go to the verification part. So first I'll show it with my real voice. Hi, this is Pratyush and my ID is 34929. Please allow me to enroll into the speaker verification portal. Hi, this is Pratyush and my ID is 34929. Please allow me to enroll into the speaker verification portal. Click on verify. And as you can see, let me just zoom this in a little bit. My voice was verified, matched with my enrollment, and that too with a very high, like, so we have two confidences over here. First confidence is how much the speaker is matching, and the second confidence is the deepfake detection confidence. So basically what this is saying is your voice matched by near 97% to your enrollment, and we are confident that it's about 93% not AI generated. Now let me use those same voice clones that I used, that I've just created, and see whether it's able to detect it or not. So you can simply add the voice clone. I'm just use any of the created voice clones.
Hi, this is Pratyush, and I am submitting my voice sample number 3 to enroll into the speaker verification portal.
And this time my verification was denied, and I was not given access because I was flagged off as AI generated with a very high confidence of 91.9%. So depending on that, whether you're using AI generated voice or not, you will be flagged off, and then your access would be denied. In addition to that, as you can also see, we have explainability as well. So we are telling whether it's a speaker match, AI generated or not, and in addition to that, what characteristics was the voice showing. So it says audio exhibits speech synthesis characteristics consistent with TTS or VCS. So that we just talked about in the opening. So as Rohan also mentioned that there are multiple TTS or VCS systems. So it says so, and that is how I generated it. Recorded my original voice. So like that's how clones are created on 11 labs. So you submit your original voice samples, it learns from it, and based on that it creates a voice clone, and so that detail is also captured with this. So this was the speaker verification part, how you are verified and then granted access accordingly. Now continuing from there, now the next part is what challenges did we face in the speaker verification. And this challenge and the challenges we faced here were very similar to that in the deepfake detection, since both they work in the audio space. So the first challenge was background noises. Like for example, I'm speaking and there's fan noise, AC noise, or let's say if you're like in outdoors, there's traffic, or any other kind of like different kinds of noises, indoor and outdoor. Then simultaneous speakers. Right now I was speaking uninterrupted, but what if someone else also starts speaking, and if that person is speaking, whether it's an enrolled speaker or not, whether it's an AI generated speaker or not. So different kinds of speaker identities can exist within a single audio stream. Then there is a replay attack. This is the one that I showed you in the very beginning. Like Now, instead of submitting a file, what if the attacker just plays it through the mobile phone, which I played it? And lastly, the device mismatch. What if the enrollment, let's say I enroll into the system through my laptop, but then I do a verification attempt using my mobile phone, or vice versa? Or if I like even if I'm on the same system, like if I'm on the laptop, then while enrollment I did not have my headphones on, while verification I did. So for the background noise and the device mismatch, we have used, so instead of working in the audio space, we went into the embedding space, and from there we unlearned these artifacts so that we can only match at the speech to speech level. So, and for this we used the Siamese net, and handled the background noise and device mismatch. For simultaneous speakers, we used diarization techniques. So if there are multiple speakers inside an audio file or an audio stream, we identify the segments by the timestamps, which speaker spoke from when to when, and then identify them accordingly. And for the replay attack, this was like one of the most advanced challenges that we faced, and even this we had to handle at the embedding level. So the embedding of the domain space and the embedding of the speech that is being entered. So we found the delta at that level, and then tried to detect whether it is being replayed or not. So if it's like if I'm if my domain space is the laptop, and I'm speaking into directly into the laptop, so it's in the same domain space. But when it comes from outside, like from my phone, or even from, let's say, any other tab or any other media player devices, then the domain space differs. So based on that, we try to capture the replay attack. Now, next is, so we also have a mechanism, a surveillance system for monitoring voice infringement. I'll just give you an example of this. I'll show you how this is right now. So what we have done is we have a celebrity a likeness portal called AI Lens. And in this, what we have is we have created a couple of POC users, and so that you can monitor their infringements across like social media websites like Twitter, Instagram, YouTube. So I'll show you the voice part. Let me just zoom this in. And so there are like multiple examples of it. I'm showing you the one with that has from Mahendra Dhoni. What we have for others as well, like we have separated them user wise for Sachin Tendulkar, Amitabh Bachchan, and Shah Rukh Khan. These are just like different kinds of deep fakes of them, circulating around social media, and how you can take it down. I'll show that as well. And then the next part, how we use our fast verify service. So first, I'll just show you this video. So this contains Mahendra Singh Dhoni and Prime Minister Narendra Modi.
माई भाई,
मोदी जी आपसे एक रिक्वेस्ट है,
बोलो ना माई भाई,
आप मेरे लिए एक गाना गा दो।
कि बोले जो बोले।
So it's clearly a deep fake. Even if not the video, like video clips are taken from original, but the audio is obviously deep fake. So we also say, why was it flagged? And we say that because it's a deep fake of like two very popular persons. Then we also give you the face match and all of the same details that we have from our speaker verification and deepfake detection pipeline. And once you can create click on takedown. So for taking it down, like, so 1 second. So takedown is only for, I'll show you with another example, the takedown link. Yeah. So once you click on takedown, you can see like this will like, once someone asks for takedown, then it will appear on the link accordingly. So the details are all pre-filled, and then you can submit for a takedown request. Now, what I'll do is I'll go over, show our fast verify service and detect this in real time. And this is where for fast we use a fast verify service for voice misuse detection for social media. Fast verify is basically an extension of the speaker verification itself. However, it like in that you do not need to enter your speaker identity details. We find the speaker enrolled, and then we find whether it's a deep fake or a real, and like all the same processes that were there in the speaker verification, the same quality control checks. So this was the use case that I'll be demoing. So this was the one where, let me just directly open this link. Okay, this is here. Now let me go to the fast verify. So this is a fast verify portal, and this fast verify portal is attached in the speaker verification only, so you can like directly click on it and access this anytime. So so here, instead of like just uploading your URL or uploading your voice or submitting a URL, a WAV file or an MP3 file, you can also work with social media URLs. So you simply copy this URL, paste it, and just and click on verify. So while it verifies, currently we have URL support for Twitter, Instagram, LinkedIn, YouTube, TikTok, ShareChat, and Mojap. So these are the 8 platforms we support right now. So like, do make sure when you're using the fast verify service, you have you're using URLs from these platforms only. And so just waiting for the results to come in. So like since this is a social media URL, it usually first fetches that the results are here. So you can see, so Mahendra Singh Dhoni and Prime Minister Narendra Modi both have been detected into the audio video stream. So we have already pre-enrolled both of their voices. So you can see from what timestamp to what timestamp MS Dhoni was there. Was it a speaker match based on our enrollment, and what has been flagged off as. So as you can see, it's an AI generated voice, and most impressive part with a not near exactly 100% confidence, and the same explainability that we had for the regular speaker verification. And then for Prime Minister Narendra Modi as well, from what timestamp to what timestamp was he there, flagged off as AI generated, and the confidence with which his voice was flagged as AI gen. So this is how you can use the fast verify. I'll also I have another example at hand. This is of Sachin Tendulkar. So that if you could see in that same slide, what we had was Sachin's voice. So I have this exact media, I've downloaded this. So
मेरी बेटी
So before I play this, just to give you a context, this video of Sachin, his deepfake voice was used to promote a betting app.
इस समय यह गेम खेल रही है जिसके बारे में हर कोई बात कर रहा है, एविएटर। वह स्काईवर्ड एविएटर क्वेस्ट ऐप खेलकर हर दिन 180।
So this is that deepfake, Sachin Tendulkar's deepfake voice. I'll simply go and check. Sorry, this is here. Can you click on verify? So just to like be sure, so right now like it might take a bit time, but like we're all like already moving to different like a different machines, so the services will get faster. Yeah, the results are there, and as you can see, so Sachin was in the entire video, so the entire timestamp belongs to Sachin. Speaker was matched. It was an AI generated voice, and again, yet again, near 100% confidence that it was a deep fake. So this is how the fast verify pipeline works. You can also do it with file uploads. This one was by a file upload or any social media URL. I'll continue moving further. This is like now I would like to hand over to Rohan. Like he'll talk about the other applications, and then I'll show you the demo of an online meeting as well.
Yeah, Pratyush, you can maybe just stay on the slide. I'll just
Okay.
yeah. So as Pratyush showed, there are many attack vectors that are possible with respect to voice clones, right? And now I'll just quickly walk through some of the applications that we are also looking at. Like for example, in the case of law enforcement, the police force gets a lot of calls to the police control room, right? Which need not be real calls, so they could be deepfake calls. And so we are in early discussions to see if we can flag those, to our police team on time. So let's say they get a call, and immediately after that, we're able to, within seconds, we're able to tell them that this is a deepfake call, right? Similarly, in banking, there is a use case where sometimes you have transactions for which the bank needs to verify whether the transaction was made by you or by somebody else. So they will call you to ask, did you make this transaction? Or they'll ask for some identification. Now, at that point, if a attacker has your phone, then they can also say yes, right? And the banks don't have any way to verify that the person who's saying yes is actually Rohan and not somebody else. So that's another use case. In the case of recruitment, what has been strangely noticed is that there's been a lot of cases where the person who has interviewed and passed the interview is different from the person who has joined, come for the joining. Because now again, people keep their cameras off, and you don't know who's on the other side, who's speaking, and all of that, right? So those sort of recruitment scams are there. And lastly, online meetings like the meeting that we are on. So Pratyush will show you a demo of how on online meetings like this we can detect deepfakes in real time. So the technology is there to deepfake anyone in real time. So you can just swap my face as I'm speaking, and somebody else will be there in front of me. But we have the technology where every 15 seconds or so we are able to tell you that there is a deepfake person on this call, or the voice of somebody is deepfake on the call, right? So those are some of the applications. Pratyush, maybe you can do a quick demo of the online meeting use case, and then we can probably open it up to questions.
Sure.
Yeah.
So continuing on. So I'll give you, so this is the, as Ron just mentioned, all the features of the live, so we call it liveness detection. So let me just play this demo clip.
Hello, everyone,
I hope the sound is audible in this.
Yes.
and I welcome you all to this demonstration of our liveness detection and speaker verification systems. To start liveness detection in real time, enter your Google Meet link into the app, enter your speaker enrollment details, and if you have not enrolled yet, make sure that you are enrolled into our system through our speaker verification portal. Add the speaker to the pipeline, spawn, go back to your meeting, and at this point, our deepfake detector agent will request entry into the meeting. Kindly allow it in. Here it is. And from this point onwards, our liveness detection and speaker verification has begun in real time. For this demonstration, what I'm going to do is, first, I will play an AI generated voice clone of mine that will be dubbing on top of me, and we'll see whether our speaker verification is able to catch that deepfake or not. After that, what I will do is, I will stream from another device from which a face swap of mine will be streaming into the meeting.
So just to give you a context, in this I played a voice clone, and then I swapped my face with another one with a using br.ai, and then played my voice clone in it as well.
And it will be speaking through an AI generated voice clone as well. So first, let's start with my voice dubbing.
At that time, I noticed a big gap between the revenue expectations implied by the AI infrastructure build out and actual revenue growth in the AI ecosystem, which is also a proxy for end user value. I describe this as a 125 billion hole that needs to be filled for.
And this was an AI generated voice clone dubbing on top of me. Now, what I am going to do is I am going to play a deep fake face swap of mine into the meeting.
At that time, I noticed a big in the AI ecosystem build out
You can see now
and actual
a deepfake has entered into the meeting.
revenue growth in the AI ecosystem, which is also a proxy for end user value. I describe this as a 125 billion hole that needs to be filled.
Since our results have started coming
So
in,
now, like once your stream is over,
in the
and the
meeting,
results
let's
are
get
out.
back to the detection results on the dashboard. As we can see, some results have
I'll just pause and give you an overview of how the our liveness dashboard looks like. So you have the analysis history, the speaker verification match, spoof detection, and all other visual aspects as well. And here we also have like not just the speaker verification and spoof detection, but also lip sync detector inside the inside the live meet. So usually, even if if you have like a perfect lip sync over your deepfake voice clone or any other person who does it, we also detect that part as well.
have already come out, and we can see some deepfake signals have been detected by our pipeline. So the results come in chunk by chunk. So let's click this first chunk and see what is in there or not. After that, what I will do is a face swap of mine will be streaming in. As you could notice, this was me speaking in my original. The other metrics related matching to the enrollment, and also it's not a deepfake as well. Click on this chunk, for example, and
Playing a chunk where it was
see
fake.
what's inside it.
Describe this as a 125 billion hole that needs to be filled for each year of cap.
So this was the chunk where the video snippet where my voice clone was playing, and as you can see, this one I'm showing you the relevant part. In this one, both. Let's just play this.
Of a face swap. And let's play and see what's there in this chunk.
Noticed a big gap between the AI infrastructure build
So in this, my face swap and my voice clone, both of them were playing.
out and actual revenue growth in the.
The
And
visual
as you could see, we detected both of them. Speaker match, who's speaker, deep fake or not, and any face swap as well or not. So this was like how the liveness detection works in online meetings. And we also have email and WhatsApp notifications. The moment you see a deep fake, you will get an alert on your WhatsApp as well, and also like on your registered email. Just if I can show you like how this works. So this is how you get deepfake alerts, like whenever a deepfake is detected in a live meeting. So like if you are an organizer of an interview or any other meeting, and like someone is using deepfake in your meeting, you'll get notified accordingly. And this is the next part. So like this is the one of the last parts. So we also have deployed our voice authentication on edge devices, so wherein it's completely offline. And these days, like a lot of like performance on offline devices is one of the most important factors. So we have a solution for that as well, and we're currently in process of building an SDK for it too. I'll just show you a quick demo of it. And it also works completely in airplane mode, no network or anything. And as you will see, it detects and verifies as well within matter of 1 seconds at max.
Hi, so this is our application and it has two main functions. First is spoof detection and second is speaker verification. Spoof detection means if we give it a sample voice, then it can detect whether the voice is synthetic or some text to speech or AI generated. And speaker verification means if I give it a sample, then it can verify it if the voice sample belongs to a particular individual. But before I begin, let me turn on my flight mode, because our app is completely capable of working offline without any online API calls. So for spoof detection, I'll show you a
So this will be running throughout in airplane mode only.
sample. Let's take this one. Listen to the audio.
At that time, I noticed a big gap between the revenue expectations implied by the.
So this is our audio sample. Let's analyze it. So as you can see, with 89% confidence, it is detecting this one as spoof. And if I select some other audio, maybe
नहीं मिटेगी.
as you can see, it doesn't really depend on the language. Even for this sample, वो आराम से confidence with confidence 86 आराम से वो spoof detect कर पा रहा है. Now if I move to speaker verification tab, then I have a section for registered voices and I can manage.
So just to show you the result. Yeah, so this is how it detected it. So this was Rohan's voice clone, and it did around like 3000 like around 3700 milliseconds. So like that's how fast it works. Now for the verification part.
To speaker verification tab, then I have a section for registered voices and I can manage. Here I can add my name and record my voice, and it will save that voice fingerprint with my name.
So
And
again this one in only around 2600
if I
milliseconds.
record and verify it later, it tell that it is me speaking.
So this is just the enrollment workflow. Like you enter your name and voice, you do it here as well.
81% confidence, it is able to tell that it is me speaking. And there is also a feedback on the downside. It doesn't really.
So if you could see, like once you upload your voice and then you click on verify, so it gives you the same thing, your verified identity, the confidence. And this happens in around, again, a matter of just like 1 to 3 seconds at max.
really depend whether I speak in English or in Hindi. अगर मैं हिंदी में भी बात करूं और अपने सैम्पल को रिकॉर्ड करूं, तो भी वो बहुत इजीली डिटेक्ट कर सकता है मेरी ऑडियो. See, with 78% confidence, it is able to detect my voice even if in Hindi. So
ये मेरी आवाज है जो कि मैंने क्लोन किया है, देखते ही इस वॉइस से मुझे एक्सेस मिलता है या नहीं?
as you can see, this is my cloned voice, and it
Sorry.
see it is able to detect that this audio is actually a clone. It shows that this voice that I uploaded has 66% match with my
So
voice,
just I'll show
but
the
it could
exact
not
clone
because it
detection
used
part.
such.
Yeah. So as you were saying, 66%. So this is the one. So the Hindi clone was also detected. It gives you the confidence and like whose voice was it. So this was an overview of the working of our speaker verification and deepfake detection on edge devices, and like mainly to have it in as low latency as possible. And like lastly, this is like if you want an early access to sign up, you can simply visit our link, visit contentlens.tech and directly sign in with your LinkedIn account. So I have a full end-to-end documentation for it, which I'll be sharing with you all, and then you can simply go and register, perform the enrollment verification, fast verify, and on anything that you like. So this brings us to the end of the demo, and if we have any questions, like we're ready to take now.
Hello.
So yes.
Yes, Samandeep.
Yes. Hi, Pratyush and Rohan Sai. First of all, I love this session, and this was here the best one so far in this workshop. I have a question. Like, you use the video of MS Dhoni and Prime Minister Narendra Modi to check if it was a deepfake or not. Like, when you're using that, does it just take the voice as to check the confidence, to check the AI or real, or does it use that lip movements or like the speech patterns to detect that also?
So first it only takes out, so this is a speaker verification, so it only extracts the audio, and it works at the audio level. So it tries to, again, as you see, like frequency levels, spectrograms, they are also like the features based on which it's dependent on.
Yeah.
And that is how it accordingly classifies and gives you the result.
Okay, and if people like, there's like 11 labs you showed using the audio from there, and is there a system like your model can suggest, tell that this audio is from 11 labs or this audio is generated from any other app, that kind of a thing?
So right now, like exactly what app it is coming from, that is something we do not have. We only give you like explanations that it is a text to speech, a VCS, and even like if it's a codec replay.
Okay.
So we give you that like meta level information, but for the exact, whether it's 11 labs or like let's say like voicedouble.ai,
Yeah.
this is something like exact details.
Yeah,
It is not there.
yeah. Pardon me. So in response to this question, so it's of course it's a open research directions now. Currently, from last 1 year, we are looking into that. Mostly like from which source it is generated. Okay,
Yes.
so that we are tracking. You can see the interspeech last year special session which we organized, the tracings of the synthetic voice origin. Okay, so there are many publications in the open source. If you are interested, you can look into them.
Yeah, sure. And like if a student wants to enter into this field, what kind of project should we make, or like?
Okay, so there is a predefined data set called MLAD data set, which has the whole source tracing like protocols, how you can they have the speech files, and along with the which source it is generated, all those things are there. So, and also they have a baseline. So please look into that, and you can get, there are also if you see my Google Scholar account, you can see also there is a STOPA data set. Okay.
Yes.
So these are openly available, so you can download those data sets and you can start working on those directions.
Okay.
So it will tell like from which origin it is generated.
Sure,
Yeah.
sir. Thank you.
Yeah.
Any other questions? From Nigerian students, any questions are there from your side? or any of
No,
our
sir.
faculties? Yes. Yes, Basil.
No, sir. No, sir. No, sir. There is no any question from my side.
Any of our
Okay, so
faculty
overall,
members?
I can give a final remark here. So, as Rohan and Pratyos has done a very good work, and they are showing the demos how in their industry they have implemented the technology what we have discussed yesterday. So, you people, I will suggest, like as Pratyos mentioned in the last slide, that the link how to register and access this. So I will suggest all of you please register and access these platforms and see how exactly these demos or the systems are working. Okay, and also give some feedback if you are seeing that something is missing somewhere and all. So please add that to the feedback such that it will help us also for further improves the systems. Correct. Yeah, that's all from me.
Like just to like add on to that, like whenever you are on the speaker verification portal, so like whenever your results are generated, please do make sure to click on whether the feedback or yes or no. So like that also, like that will help us. So the button will come right over here, or like if any other feedback, personal feedback, you can reach out.
Okay.
Perfect. Thank you. Thank you everyone for attending the session. Thanks, Pratyush.
Thank you,
and
Mr.
everyone.
Rohan and Pratyush. Thank you very much. As participant told that very nice session. So thank you, Dr. Jagabandhu. So anybody like to start any work? So definitely, I'll be in touch with all Rohan, Pratyush, and you also. So thank you very much. So next session will be at 12 p.m. So let us join. So you can note down, Jagabandhu sir has already shared the data set in the chat box. If anyone wants to interested somewhere there, especially for you, you can note down. Huh? And definitely video will be shared today only, that will be uploaded. Thank you very much. So thank you,
Thank you, Dr.
once
Das.
again, Mr. Rohan and Mr. Pratyush. So
Thank you, Dr. Das.
Thank you, thank you very much.
Thank you, Dr. Das.
I'll be in touch with you.
Yes.
Yeah.